Exothermic reaction. What if I told you that some chemical reactions can produce heat all by themselves, without any flame at all? Today, we are going to investigate that using a simple neutralization reaction. Let's break the whole process into 4 clear steps. Step 1. Equipment setup. Before starting any experiment, we need to set up our equipment properly. For this investigation, we are using 2 beakers, a measuring cylinder, a thermometer, a stirring rod, dilute hydrochloric acid, and dilute sodium hydroxide solution. Everything is simple, but each piece of equipment has a purpose. The measuring cylinder allows us to measure accurate volumes. The thermometer helps us detect temperature change. And the beakers allow the reaction to take place safely. Now that everything is ready, we can begin. Step 2. Measuring the reactants. First, we measure 20 cubic centimeters of dilute acid using the measured cylinder and put it into one beaker. Then we measure 20 cubic centimeters of dilute base and put it into the second beaker. Before mixing them, we need to record the initial temperature. We place the thermometer into one of the solutions. Both are at room temperature, about 25 degrees Celsius. This is our starting point. Right now, no reaction has occurred. Step 3. Mixing and observing the temperature change. Now, we carefully put the acid into the base and stir it gently. The moment they mix, a chemical reaction begins. Watch the thermometer closely. The temperature rises, and we didn't apply any external heat. So, where is this heat coming from? This is a neutralization reaction. The acid reacts with the base to form salt and water, as you have seen in the previous videos. But during this reaction, chemical energy stored in the reactants is released as heat. The released energy is what caused the thermometer reading to increase. You might notice that after reaching a peak, the temperature slowly decreases back to room temperature. That doesn't mean the reaction becomes endothermic. It simply means the reaction has finished, and the extra heat is gradually lost to the surrounding air. The key evidence is the initial temperature rise. Step 4. Explaining it with an energy profile diagram. To understand this fully, let's look at the energy profile diagram. Here are the reactants, the acid, and the base. They begin at a certain energy level. For the reaction to start, they must overcome a small energy barrier. This is called the activation energy. Once that barrier is overcome, the reaction proceeds. Now look at the products. They are at a lower energy level than the reactants. That difference in energy doesn't disappear. It is released to the surroundings as heat. And that released energy is exactly what we observed when the temperature increased. So if the products have lower energy than the reactants, the excess energy is released. Released energy means heat. Heat released means the reaction is exothermic. That was all. Thanks for watching. Stay tuned until the next videos.